Hello again. Now we will speak about the second example, which is MNIST dataset. What is MNIST dataset? If you just search for it, it's a dataset for handwritten digits from 0 to 9. And For each of them, each of these digits are image. It is 28 by 28 pixel image, and the purpose is given this image, the purpose is to predict which digit it is. It is 0, 1, 2, or whatever until 9. And this set was trained and was solved by a lot of uh, artificial intelligence methods like neural network, deep neural network, convolutional neural network, whatever it is. And this is not the purpose of this class. Just we will use this model and put it in cloud um, platform to do the prediction. So for now, um, let's go to our repo again, like this. And in our repo, there is a folder called mnest. And for this mnest, you can see there is uh, mnest.txt, which has the commands that we will use today. As in the previous video, this link contains the source of the tutorial. What is not exactly we are using here. We added a lot of features, but we're starting with this source. So um, if you wanted to check the original, go there and check. So we will start to clone this repo in your local machine and um, in your cloud shell, like going to the cloud shell, right, like this, and just in home directory, just clone this repo. And when you are cloning this repo, you will find that there is code and there is data. In data, the three files starting with export are the machine learning model trained outside the cloud, but just we will use them. And images.txt um, for it. Okay, it's a huge, so it won't be displayed right here. But image.txt is the input, the data set of the image that we will use. So let's go to our editor right here. And now, after cloning, there is a new folder called SOFE4630U tutorial 4. If you open it, you'll find mnest, and in mnest, you find data, and in data, you find image.txt. If you open image.txt, okay, it's a huge. I'm not sure that will be opened here correctly, but let's try. If not, we can open it like in my machine here. Let's go to mnest, data, and images.txt. This looks like this. It started with a key, the key which is the index here, index for the image, for image 0, image 1, image 2, and so on. And after this, there are 28 times 28, which is like 800 value. This is the value of the first pixel, that is the value of the second pixel, and so on until the end. Zero here means the white, um, and one means black, and values between 0 and 1, which is the difference levels of gray between white and black. So here is the value in it is not binary, it is in a text format or a string format. Just that is the inputs that we wanted to predict. And for the whole of dataset we have like 10,000 image, and this 10,000 image we wanted to classify them to predict what is a digit. Okay, let's return to our repo and it's open now. Okay, so let's return to our repo and our code. So here, after we clone, there is a new folder called SOFE tutorial 4. Copying it and change directory to this folder and list what is it. There is an folder is called mnest, and in mnest there are a lot of codes like predict version 1, predict version 2, predict version 3, and version 4. Actually, predict version 4 contains part of version 3 and adding a feature to version 3, and version 3 is the same as version 2 but adding a feature and so on. So just it is you can consider it like one program, but it is written bit by bit. So uh, now let's try to follow the instructions and to understand what we will do. Okay, so we shall not forget to switch it to the environment, the virtual environment that we created before, which is source environment bin activate, like this. Um, okay, and let's start with the first code, which is predict version 1. Okay, now we have some experience about reading and understanding the code that is written uh, for Dataflow. So let's start by parsing arguments. There are four arguments can be added. One of them is the input, which contains the input source, which here is the file images.txt, and the output, which for each image a prediction will occur and its value will be printed. And also like parse add argument, and for this add argument sorry, this is parse add argument model, and for this model this is the folder which will contain the model, and as we said before the model is a three export files, and there is a source here will choose the mode in which we uh, will run this exercise example on it. And for the first version there is only one mode, which is text. In this mode the input and output will be text files, but we in version 2 we will add another mode, which is MySQL, which is the input and output can be MySQL databases, and in the third mode will be Kafka. Um, there are there are the acceptable and the required modes from you that you can run your application or run whatever processing on it. But there are another two optional will be added in the next video. One of them using what is called PubSub, which is like Kafka, but it is implemented especially for Google Cloud platform, and also using something called BigQuery, and BigQuery is also another interface that is made for Google, um, and it's like interface to database inside Google Cloud. Uh, there are the last two modes are optional. You can skip this video if you don't want to listen to them, but they are added as an external, as an additional resources for you. If you want, if you don't want, just skip the next video. Okay, so for the mode of text, if the source, and here is a source, is text. That is the pipeline that we want to implement. The first of this pipeline is read from text that we have seen before, that takes a text image, a text file, and read it line by line. So the output of this pipeline will be a list of lines. And we know that each line is in this format. It is a key, then colon, then image. So to parse this, we will do a map function, and in this map function we will call a function called toDictionary, and that is the implementation of toDictionary. To dictionary is just take each line and split it. The input to this job is a line. So for each line, that's the element input, will split according to the column to before colon and after colon, and before colon will be put as result.key, and after the column will be result.image. So this will generate a dictionary, a JSON-like object in Python that contains just key and image. Okay, then uh, the image here as a dictionary will be fed into a new job, which is prediction do function. And prediction do function is another transform. It can be implemented like PMap, but it is done like a class. We'll see the implementation of it because using class provide us with more flexibility, as you can have um, some private variables, some functions that we can use like private functions and so on. So this provide us with more flexibility. So if your transform is done by a function and it is one-to-one, you can call pm.map, and it is done by a class, you can call what is called pm.pardo. So let's go and see what is this prediction do function. This prediction do function class. The class is called the prediction do function. So let's go back here and see. That is the class, and it inherits pm.do function. And for this class, it will call a function called process for each element. When you have an element to process, this function will be called. So for each element input to this job, this function will be called, which is called process, and it will have an input, which is the element from previous jobs, and also this will be another argument, which is the model. So the input to this function process will be the element and the model. So we just will create model. We are this code is not the scope of this course. The scope of this course is the cloud platform itself. So if you are not familiar with neural network and the models of it, uh, Don't be afraid. That is not our interesting. We will use it like a tool. No, no, we don't no, need you to understand this code. If you are not understanding it, just you can replace this with any codes that do any processing, and they can input and provide you an output. But we can go to this model. We will generate a model according to the data stored in this path, the model path. And for this model, we'll take the key from the input element and convert it into integer, and also the element m.image, which is the second part here, and split it according to the comma. There's a lot of commas here, and so we will split it into commas, split it by commas, and convert the result into float, and it would be stored in image. Then this will be the inputs to our model, and our model will do its job and give us a prediction, and the output will be output key and the prediction. The prediction is like the probability of that image being 0 or being 1, being 2, being 3 until 9. So we have 10 probabilities, and the probability with the highest value means that this image is more likely to be that digit. For example, the probability of being 3, if it is the highest probability with those, this means that this image more likely to be 3. Uh, so who does this? The model. How? We don't care. Just the model does this. Then this is a result which we will return, and in this result we will put a field called image key, and this image key will be the output key, and the prediction, which is model.b, and this prediction um, we'll start with this prediction like sorry, this prediction was given from here. So this prediction will convert it into list from numpy into list, and we will iterate into this list and add the first at result.prediction 0, and the second at result.prediction 1, and so on until result to prediction 9. And here is how prediction 019 is generated, just prediction, and each percentage d will replace with the value of I, which is as the first iteration will be 0, 1, 2, and so on. So this code will generate a dictionary with 11 element, 11 key. The first will be image key and 10 predictions, and will return that. So this function will be called whenever an element needed to be processed. And in brief, what it takes an image from a previous job and do some machine learning modeling and output a prediction as a dictionary. And then this prediction will be sent to an output text file to be written in. So just we will use write to text, and that is the program. Okay, how this model is done, that is not our concern, but it is done using another class called model, that using a library called TensorFlow, which is like this. It reads export file from the model path, and then do some prediction on it. Uh, that is not our concern, but just you have to know that we need this function, this library, which is TensorFlow. So if you want to run this, just go here and install TensorFlow, and the TensorFlow used here has a version of 2.8.0. So just you have to install TensorFlow CPU 2.8.0 to run this uh, data flow code. So we'll start to be installed. Subject here, sometimes we are installing a lot of libraries, a lot of Linux command. The drive will be full, and to check the drive capacity, you can use the command df, and you see that the home directory is just it's nearly 40 percentage, so it's okay, but it is 100 percentage will be problem. No new libraries will be could be installed because it is full capacity. So what you shall do, if this is the case, just search with ls hyphen la, which all files will be shown in long format like this for the home directory, and all the folders that starting with dot means that it is hidden files, as hidden folders or hidden files, and those are temporary, not required. You can delete them, and you will free a lot of space if you do this. If, like my case, you have a lot of available spaces, that is okay. Don't do that. Um, just you can run this code in local shell like here. What you need is to run prediction version 1.py, which is a file that we have read um, here, that is file. And to do this, you have to provide it with some um, parameters, arguments like the input, which is the place can read input data from, which is in the current directory in data, and you can file it as in image.txt, and the output will be stored in predict um, as a predict in the local directory, in the current directory. Also, the source will be text, as we said before. The source uh, control this if statement, and for now, just there is only one option which is text, but there will be another option in the next versions. Okay, the model will be in data folder, and will start with prefix of export. Also, we need the temporary location, and another location for the neural network is called staging location. So we can provide these commands and run it in our shell like this. Just for now, I'll delete this line. I return to it, but for now, let's delete this line. So it start to run locally, so it will be faster start, but will take a lot of time. So what is the problem here? Okay, let's check what is this. Okay, this is a problem here. So the problem is for the function um, write to text, and Okay, it's not the problem. Problem is here. I change this and don't save it. Let's save it and run it again. Okay, this is my mistake. I have changed the format of the file, the image.txt file, but it should run and work now. Now it is working and everything is done. And if you can see, there is a predict file here. You can open it and see the prediction like from the editor. Open predict like this, and here is our result, which is image key. For image key 0, the prediction 0 is 7 times 10 to the power minus 30, which means nearly 0, and this is nearly 0, nearly 0. You can go there, and all of these are nearly 0 because this is too small. This is 10 to up to the power minus 14, so on, until reach prediction 7. It's nearly 1, which means that this image is more likely to be 7. This is the image of digit of the digit 7. For the second image, it is more likely to be 2. It is almost 1 in the probability. So just you are searching for the digits that has the highest probability and see that is more likely to be 2. Okay, so for now, if we want to run it, run this code. Let's clear the screen. Also, let's close the step here. Okay, if we want to run this code over cloud, not locally here. So what we need, just we need to, as we did before, get the project ID and get the bucket ID, and here is that automatically can be generated for the variable and got it like this. And here is the output of first echo was this, and the output of the second echo will be this. So after this, we have to copy the data from my shell to the bucket. What I need to copy is the model and the input data. So to do this, just I'll use G Suite and copy from local from current directory, from folder data, any file start with export to my bucket, and maybe in folder called model. So I don't know which is why. So let's do it. And try to copy it like this. Okay, there is a problem here. Oh, okay, there is research. There's a problem accesses this bucket. Okay, so let's try to just list all things in this bucket. So let's check for the data storage here. I hope it's correctly. So what's the problem? I don't know what is the problem. Okay, maybe some authentication. Maybe some authentication error. So let me open a new uh, shell and repeat this again, like change the directory and change the environment to virtual environment, and also run this like this. And after this, let's go and try to list all files within the bucket. So there is a problem here and maybe need I don't know, let me refresh it again and see how to solve this problem. Yeah, it's like authorization and yeah, it works right now. It's with some problem in authorization and something like this, but it works. So let's continue by copying all the model, which is starting with export of all files starting with export to from my shell to the bucket in model folder. Okay, there are three files and they are covered. And after this, I repeat this again, but now I'll move the data, which is are included in image.txt, but I move it to another folder in my bucket. It's called input. This folder will be created and image.txt will be copied to it. And we can go here and check by refreshing uh, this window and see there is model, and in model there are the three export file. And also if we go back and check for input, there is image.txt. So it's okay, it works. Okay, now we need to run this uh, over our cloud services. So just copy this code and try to this command and try to understand it. So the first thing is we will write prediction version 1.py. This is okay. And to do this, we'll use the Dataflow runner, which is cloud services. That is okay also. And within our project, this is okay. And the staging location will be in our bucket, not in locally in my virtual machine here. Also, the temporary location will be inside my bucket. All this is okay. The model is in my bucket, and the source will be text. All this has no problems. These are normal. And the input and the output will be also in my buckets like input image.txt, and the output will be stored in output predict, and the region will be North America, and Northeast too, and will use unsupported Python version. So this code is nearly this, but is customized to run within the cloud services. But there is only one line here that is a little bizarre here. This is setup file. And why we need this? If you remember, we have to install TensorFlow on my shell here, on my console here, so that this code can work, because in this code there is a need to TensorFlow library. And this work for running this code locally. But if we want to run this over cloud, there will be workers, which is like containers, and inside this worker, I have to install TensorFlow. So how can I install additional libraries in the workers? I can do this by provide a file called stuff file, like this file setup.py. And if you see, there's a lot of things here, like as a version of my code, what I need to name this code, and a lot of things. But the most important is called custom commands, and this custom command will run to set up the worker, and this will be pip install TensorFlow CPU 2.8.0. It's like an array. Each word are an element in that array. So this is a command, and if I wanted to install another command like this, just I'll have to and provide another array. So it's like two-dimension array, and each row in this array, it's like a command. And if I wanted to another command, I had to insert another row, and so on and so on. So this file will be run in each worker to adjust the Python environment at this worker before my code can run. And I had to provide this into the data flow like an input, just setup file setup.py. And that is what you need to do if you wanted to install any other library that is not by default installed in Python over workers, um, more than TensorFlow, other than TensorFlow. So let's go run this and go to data flow jobs like here, and there it is, the new one that is generated. It will be take a time like minutes or more than that, uh, because of the initialization stage for the worker, which now will include installing the setup file inside each worker. So let's wait and see what is our output. So what will happen uh, if setup.py is miswritten, if you are wrongly write the pip install command, like using wrong library name or something like this, you find there is an error that the worker couldn't start. So we have two types of error here. Maybe the worker cannot start, that's an error, as another error is the worker started but the job failed. If the job failed, this means that the Python code itself that describes the pipeline has an error in it. And not be syntax error, just an error in execution, like you are grouping by key and there is no key, or something like this, or just you are summing strings, which cannot be done. So they may be an error within a job. That is, means that the error in the Python file itself that we are running, or an error because the worker cannot start it, as this means that the error is according to an error in setup.py. Now, it's the first stage uh, still didn't start yet, but probably it worked faster than that. But here is our four stages. The first is read from text, and that read from text file, and then convert it into dictionary, and go to the prediction stage, and out of the prediction will be written into text file. And of course, you can see the logs here, and some of these logs, if there is an error, you'll see like a red icon here, or yellow for a warning, something like this. So what our next step will be? Our next step will be reading and writing um, this database or dataset on MySQL. Uh, what will be the difference? The difference will be in this stage, and maybe in converting to dictionary according to what is the format output from reading from MySQL. If it is dictionary, we don't need to do this. Just go to prediction. And also in the next stage, instead of writing to text, we will write it to MySQL, and the prediction stage will be the same. And how we can install MySQL? We will use Kubernetes YAML files that we used before in the previous milestone to set up MySQL. For Google, there are another way that you can make a virtual machine and go inside this virtual machine and manually type the command to install MySQL in it. So there are two ways. One of them is by manually install MySQL. The second is write a YAML file and apply it to Kubernetes, and that is the way we will use. Okay, we'll go to MySQL, but when um, after this pipeline finish running, and of course we will need our bucket. So go here to Google Cloud Storage, to our bucket, and here is some folders created. That is great. What we need, the output will be in a folder called output. It is not created yet. Can refresh it and wait. So while we are waiting it to run, let's go and uh, let's see the next version, which will be predict version 2. In predict version 2, we will need to read and write to MySQL. So just what we need here is to read from MySQL. So we added a new source. The first source was text, and the next source will be MySQL, like this. And to read and write from MySQL, we need another library called Beam Nuggets. Okay, let's stop here. Start to run. One stage successful. And data is flowing to the next stage like right now. And here is the element that how many elements per second get uh, processed. Now all of them are have finished. I hope so. It's still processing. So it finished and stop and now in stopping phase. So if we go to our bucket, like here, we find there is and do refresh, find a new folder called which is output, and within output there are three files for prediction, and you can open them and see what is inside them if you want. Okay, now it works. Let's return to MySQL in version 2. So what we need is just a new library which is Beam Nuggets, which is this. And to install this, we need to install it locally and also to install it over the workers. So to install it locally, just you have to go and pip install Beam Nuggets like this and run it over one of these shells. Let's open a new shell because this is not ready yet. And before run it, change the environment to our virtual environment 1. And run pip install beam nuggets. And the good news here, it is installing a Kafka Python within it. So in future, when we are using Kafka, we want to install Kafka nuggets because it is already installed in this step. Okay, and also let's change the directory to be within our I'm here in the home directory, so I'll go to our repo image and go to mnest folder. And within this, I'll find the two YAML files that we used before for MySQL. And because I have created a new project, I have to reconfigure Kubernetes. You don't need to do this because you are already configured before. So for me, I'll start configure Kubernetes. So I go to Kubernetes engine, and enable it. You don't need to repeat these steps. And I'll set the compute zone to be North America, Northeast 2A. And then I'll create a cluster with 3 nodes and get the credential for this cluster. So these three lines, you don't need to repeat them. You did this before, unless you are creating a new project. So you need to repeat these 3 lines. Now cluster is created or is creating, and it's created, and it is checked to be successfully working. Yes, we will wait a little. So the cluster is set up and can use Kubernetes after this. So let's open a new terminal and try to run the credential. I hope just okay. Okay, it finished. Let's go and run this again for credential. Okay, now Kubernetes is set up and ready to to work with it. And to work with it, we'll start by applying MySQL BVC and then MySQL app. So let's start with MySQL BVC. This is the same that you used before. And after this, MySQL app, and then we will get the services to check for the IP. So still the external IP is pending. So let's wait a little until the IP is obtained. Okay, now we got the IP. Just we can copy it into a variable, a shell variable, like what we did in the project and in the bucket. Or we can do this automatically, like instead of get all the services, I want just one service, which is called MySQL, and this will give me only one row here for MySQL. And for this, I want the output to be like JSON. And from this output, I need only the external IP from the status. So the commands look like this: Kubernetes get services MySQL, and the output I need from the JSON path, which is a status load balance of 0, then IP. Running this command, running this command will give me only the IP here, which is this, and of course I can store it in. Uh, sorry, where is it? I can store it in just a variable like MySQL IP here. So let's store it and maybe echo it to display and check this correctly set like this. And here is the output of the echo, which is correctly. So now we are set up our MySQL, get its IB, and also let's check that the bucket and the project is correctly uh, saved into our shell variables like this. Now return to the code. And this is our code. In this code, there is a new option here. We can set the source to be MySQL, and to set this, we will have an input configuration that is the input that we will use it to connect to MySQL and read the input data set from it, from a table from there. And this will be from the host, which is IP, will be given as an input. And also for output configuration be the same, but the IP will be got from the argument output. And after this, we will use Beam Nuggets library to do a relation database and read from DB with a source configuration uh, with a source information with this source configuration. This is the input configuration, and we'll seek a table called image and run this uh, query query over this table, which select all fields from this table image, and the output will be already dictionary, so I don't need to convert it to dictionary. It is already dictionary, so just I go to the prediction step and just repeat it as it is, and the output will be dictionary, and this dictionary can be written into a table automatically also. And to do this, just I need another configuration, which is table configuration. And this table configuration is a table called results, and it will be created if missing. If this table is not there, it will be created as the primary key. When we will create it is image key. If you remember, the prediction output a dictionary of 11 fields. One of them is the image key and 10 of the predictions. And to do this, the output of the prediction will be piped to uh, fit to a new job, which is relational database dot write, with the output configuration, which is the configuration of the server that I use it to write the table, and the table configuration, which is the table name that will be created and was the primary key of it. So this pipeline will take the prediction and store them into table. Okay, so uh, how shall we run it? To run it, just we want the IP to be both as an input and as an output, and to set our um, set a table within this MySQL database called image, and fill it with some data of image. And to do this, there will be within data, we'll find a file called image.sql. If you open it, it is like a SQL script that we used before. Instead, MyDB, it will create um, a table called image, and if not exist, we create image, and for this, this is the key will be primary key, and the other will be the image. There are two fields here: key, which is a primary key, and image, which is a string. And the output will be stored in result, and the result will have 11 element, image key, and 10 for prediction. And then we go to input and insert uh, some values, like here is set into image values 1 and some data 2 and some data, and so on. So this is the value will be inserted into image, like 48 values. And to do this, all we need is just run this command. We have seen this before. This command, we have seen it before. Like it run MySQL command with a user called user, and with a password, and the host name will be in my SQL IP, which is set before here. So that is the username, the password, and the IP from this variable. And after this, we will take this script, this is a query statement, and execute them in this MySQL. So let's run. It's okay right now. We can show tables, and we can run this command, which is show tables, and we ensure that the tables are created. So there are two tables, image and result, and within each of them, we can go and select like asterisk from images, and here is the values. Of course, result will be empty, so if for now there is nothing in results. And it's a result, not results. Okay. So let's go to our code and run it. But our code will generate a table called results. So we'll see two table result and results will have the values in it. So let's go and run version 2, and to run version 2 we can run it locally or globally over the cloud. So let's run it over the cloud, and to run it over the cloud all I need is just provide you with uh, the runner, the project ID, the staging location, temporary location as before, all this as before. The model and the source will be MySQL, so that this if statement is executed, and this is the pipeline that will be executed. And after the and setup, and within setup here, I have to delete this comment. I need to install Beam Nuggets also within my workers. And the input will be the IP for MySQL, and output will be the IP for MySQL and the region and all this. Let's run it. And of course, take a lot of time, but hopefully there is no problems here and it will work like this. And let's go to our data flow, do some refresh, and here is a new one, a new uh, pipeline is created, and still take a lot of time to start. So while it is initialized and working, let's go to version 3, which is the last for now. So what is in version 3? Version 3, we will do some stream, all those for batch processing. Now we will do stream processing using Kafka. And the good news is Kafka is already in the same library, which is Beam Nuggets, for a source, but for destination it is not there, so I had to write it myself. So if you open um, version 3, you will find that I write some code myself, which is producer Kafka message. This is the code that will take Kafka messages and um, write and will start to produce them. So what's the pipeline now? It takes us here to check when this work is still initializing. So what is new in this version 3? The new is we add a new option, which is Kafka. And to do Kafka, okay, that is my credential. You have to change that to your credential, like what we did before. like the username and the password for your Kafka. So you have to change those. This is for the consumer and this is for the server, and the pipeline will be like this. Reading from Kafka, Kafka consume, that is already inside Beam Nuggets, and the output will be deserialized by converting it to a dictionary, like using a nameless function, and apply for this byte JSON.loads, like we did before um, in milestone 2 and milestone 3, and then run a prediction and then do serializing. And for this serializing, just we are converting it into bytes and into uh, table of key and value. Key will be null and the value will be the predicted value, which is the element output from here, and then we'll send it to a Kafka produce Kafka message to be written into Kafka. So what is our uh, parameters here is the topic, the input topic from Kafka, and the output will be the same like the output topic on which the message will be produced. So that is a code. You have to fill some filling spaces. You will find this as an empty string when you are trying to run this code over um, your version of the repo. Just you have to fill the username and password according to your Confluent Kafka configuration, and choose whatever the input and output for the Kafka topic you need. So before running this, let's wait and check for MySQL. The serializing and deserializing is like JSON. It's the simplest way. I didn't use Avero for this. Avro for this. So just it is a JSON. It's the easiest one. And if we wanted to run this pipeline, we have to choose a source to be Kafka and provide it with the input topic name and the output topic name. So the command will be like this version 3, and for this version 3 we need the source to be Kafka, and also we need like an input and output. This will be the name for the topics containing the image, the data, which is MNIST image, and the output will be produced to MNIST predict, and we can push some images here and read from here. So instead waiting for this to work, let's just check our tools. Okay, within our repo, inside MNIST, we'll find and within data, we'll find two scripts here. These scripts are for producing to and consuming. Okay, it works. Let wait for a second. Now MySQL works, and the first stage completed, the second completed, all of this completed. And if we want to check that it's work, we can still wait for this terminal or open a new terminal. Let's wait for this, or just stop it like here and run this command, which select asterisk from mydb.results, and here is the output uh, like this. Um, Here is the key, which is 47, and the prediction for 0, prediction for 1, prediction for 2, which is up nearly 100 percentage, and for 3, 4, and so on. So the number with highest percentage, highest prediction like this, means that is most likely to be 5 for this digit, or 4. There is 0, 1, 2, 3, 4. So this digit is more likely to be 4, and so on. So now MySQL has successfully run. Let's go to Kafka again. Uh, so what we need is to produce some data. So this is producer um, for MNest. And for the producer MNest, we will follow the same as the third milestone. We have a credential in JSON file. It will be like this JSON credential file. You have to fill the Bootstrap server, the API key, and the API secret for Kafka, for your Kafka. And then we'll read this JSON, and getting the credential, we can connect it to producer, and then we'll open image.txt, which contains our dataset, and parse line by line and split it by colon. And after this, we take the first parameter as a key and the second as an image. And after this, we will produce this value. And to do this, we are doing the serializing using JSON serialize command, which is the simplest one, and printing that the image with a certain key is sent. Wait a little, and then go again and produce for the next line, and so on until the whole file is sent. So this is our code for producing, and also for consuming will be the same. If we want to consume, uh, it's the same code as before, but here we will consume from mnest predict and also the credential. For this to work, first we need a credential. You have to fill yours. I have mine filled here, so I copy this and replace a file here. That is for the beginning, and also go to Confluent Cloud, Kafka Cloud, and log in. Oops. Your email and your password. and go create two topics, one for MNIST image and the other for MNIST uh, predict. I believe I do this before, so I find these two topics here, but I can open each of them and delete them, like from configuration and delete topic. So just I have to copy this here, continue, and delete this topic. So let's start from a blank configuration. What you need to do is to create these two topics, and to do this just add topic and let's call it mnest image. I'm not sure it is image or images. Let's check. This will be called image. So now let's create it with the default values and also go to our topics and add a new topic which will be called mnest predict. There are two topics. One of them will have the input and the other will have the output. So we'll create with default. And now we can run our code. And to do this, all we need is go to our repo and run this command that sets Kafka uh, uh, streaming pipeline like this. So go back and you will find that there is a new one that will be created and you will wait. Okay, it is running and the emit is 0. That's okay, it's cool. So now um, let's go to this path and uh, run produce mnest like here, which is trying to produce to, oh, it's too fast. Okay, let it leave it like here. Still not initialized, so we will wait until it initializes to start work. You can check it is working by seeing how percentage it is running, or by the output, how many throughput output element per second here. Uh, Still initialized, hope it finish soon. But while we are waiting, let's open a new command and change directory to this directory and run consumer, and here is our consumer. So when this pipeline is working, the data will be consumed, the data will be it will work like this. The data that are produced here will be consumed with the pipeline and doing the processing on it, and then inserted back into the topic, which will be consumed here. So we are producing data, send it into a topic. This will be consumed with the pipeline, and pipeline will produce it to another topic, and the data that is sent to this other topic will be consumed with this code. Okay, we have put a let pause it like here until it start working, and we will wait for some minutes until the worker are set up and start working. Okay, that is the final step in this tutorial. And as we said before, the next video will be optional. We'll have another two modes rather than Kafka, MySQL, and text. Uh, if you are interested, go and watch this video. If not, just skip it. Okay, now what is required from you? You suppose to design an application uh, using the dataset you have uploaded in the third milestone. Uh, you have to search for application that will be practical application and to design a pipeline for that application. Uh, and this pipeline that we'll design will implement it in the next milestone, and this will be the final project submission from you. Uh, if you couldn't find a suitable application for this dataset, just search for another dataset that is suitable for you. Uh, but it must have two important properties: must have a variety of information, not just one table, maybe many tables, maybe tables and images, whatever it is, just a variety of information and a huge size. Both these two attributes are important to be implemented in over cloud. If it does not have a variety of information or a high volume, it is not economic or not suitable to be implemented over cloud. So still waiting for the, the pipeline to be installed and to work. And it is working. You can see that is running is 100%. So it is working, and now let's go. Okay, now we are producing, and this is consuming the results. Just if you highlight any part of the command window, this will pause, this window will pause, and of course, all of the steps will pause, waiting for a new messages, and just click enter, and it will resume and work again. Okay, congratulations. What we did for these videos, we got some good information about data flow, how it is implemented, like MapReduce pattern, or how to use different input-output sources for our processing, like text file, MySQL, and also Kafka. The last thing here, okay, let's stop this and maybe stop this. This is a stream, which means that it will work forever. So if you wanted to save your credit, you have to stop it yourself because it will work forever, waiting for any message to be produced to process it and put it into a Kafka. And if it is none, it will still waiting. It will not finish alone. You have to stop it yourself. So if you want to stop it, just go to stop and click it. And maybe not stop job. Okay, do nothing. A clear selection and stop job. Okay, go back and you'll be set that is canceling right now. And by now you we have finished uh, our 5 examples of using Dataflow. Thank you for listening. The next video is optional. Bye.